This will be our lecture video on atmosphere and wind and how it relates to plants. There are three important gases that make up our atmosphere. Yeah, there are many other gases in the atmosphere, but the three important ones are nitrogen, which is about 78% of the atmosphere, oxygen, about 21% of the atmosphere. Right now there's about 409, 410 parts per million of carbon dioxide, and all of the rest, that last 1%, including the carbon dioxide, is everything else. Right? So we're always worried about carbon dioxide. So now the important part here is to think about the outsized dynamic that carbon dioxide has relative to the volume of carbon dioxide in the air. Nitrogen is relatively non-reactive. If we look at nitrogen in the air, it's N2. It's very difficult for plants to get to that. We need to convert it to ammonium or nitrate for plants to be able to utilize that, and we do that through chemical processes. Lightning does that. Fungi can do it. We can add fertilizer. But bacteria and fungi are the two main ones that plants will interact with, and those organisms can actually take N2 and other forms of nitrogen and convert it into plant usable forms. Oxygen is very reactive. It is released during photosynthesis and used during respiration. Plants have the same respiration processes that people do, but they also have this photosynthesis that makes oxygen. Interestingly enough, here's a fun fact for you. If you go back several 100 million years, the oxygen levels in the atmosphere were next to nothing. Because of its reactivity, oxygen can be actually a dangerous gas. And so if you go back millions and millions of years ago, there really wasn't a whole lot of oxygen. The reason that we have an oxygen layer is because little organisms figured out how to do photosynthesis. They figured out how to do something great with carbon dioxide and started releasing oxygen into the atmosphere. So the reason we actually have an atmosphere with oxygen in it is because of plants. Particulate matter is something that has a great impact. It affects the amount of light. It impacts the temperature. Think of things from the ash from fires, volcanic ash, and the erosion that wind can cause. Particulates landing on your plants can reduce light penetration. They can increase heat retention. Where might these particulates come from? Well, obviously you've got things like fires and volcanoes that don't happen very often, but pollution can happen, and in a home situation or a commercial landscaping situation, you might be talking about dust. This is obviously an extreme situation. This was ash left over from a volcanic eruption, so this is going to be something that these plants are not going to be able to deal with long term, obviously. This is ash from a fire, so obviously these crops are going to be detrimentally impacted because of lack of photosynthesis being due to the ash that happened from a fire. More commonly, what we see is particulate matter from pollution. So you're downwind of a factory or something along those lines, and the particulates emitted from the factory landing on your crop plants, and that can negatively impact their growth. Not only can they be negatively impacting just because they're blocking light from getting to the leaves, but they could be toxic particulates as well. This was an interesting study that was done with soybeans, which I thought was an unusual plant to do this with, but it's a study on exhaust fumes and their impact on plants. So the plants at the bottom of the picture had exhaust fumes pumped onto them on a regular basis, and the plants at the top did not. Now, I thought this was kind of interesting because we don't normally think of crop plants as having a lot of exhaust because the tractors are moving through the field. But think about from an ornamental perspective and sensitive plants being placed in drive-throughs and next to driveways where we might be parking our cars and letting them sit and run for a while. This was a white pine that was impacted by being downwind of a factory. So you can see the damage being done to the plant there. That's pollution. For you indoor growers, you're going to have a bigger problem with ethylene. It's not an issue outdoors. A little tiny breeze blows it away, so we don't have a problem with this outdoors. Indoors, most of our motors will produce some amount of it, our coolers, our storage facilities, our heaters. It is a natural plant hormone, so plants will produce this as well, and they use it for ripening their fruit and senescence, meaning when we're getting ready to drop our leaves or we're getting ready to drop our fruits off of our plants, they're utilizing a chemical hormone called ethylene. Too much ethylene, however, will distort your growth, results in premature aging, and fruit ripening faster than you want. So you know that whole phrase of one bad apple ruins the bunch? The one bad apple goes bad, that apple goes bad, and the next thing you know, it's producing ethylene, and it causes all the other apples to go bad. The take home here is to notice what the blue is. It's a natural plant hormone. Some of these things are good. We need leaves to drop in the fall. We need fruit to ripen, but too much and you get distorted growth and senescence. Now, this is what's normally in the air. 5 to 10 parts per billion. Not very much. But 1 part per million is highly active for our plants. I'll give you to show this here. This is something that floral growers have to deal with all the time. The instant you cut the flowers off of the plant, they start producing ethylene, and that causes them to ripen faster. Too much ethylene in your storage coolers, and that can cause problems. So if you look at the plants on the right-hand side, that's 1 part per million causing senescence or death in those flowers, and those are no longer usable as far as the floral industry is concerned. So you greenhouse growers, you homeowners, and you indoor growers, you cut flower growers are going to be dealing with this, but also anybody who ships plants or ships fruit anywhere across the country is going to have this problem. Wind is driven by atmospheric pressure differences, and the Earth rotation is what causes the whole thing. If the Earth were to stop rotating, we wouldn't have wind. Right, so I'm not worried about whether or not you remember that, the warm winds from the south in the summertime and the cold winds come from the north in the wintertime. That's pretty obvious stuff. All right, we know that wind is going to be impacted, and we know that for most of our outdoor growers, there's not a lot we can do about the wind. But if you are dealing with ornamentals, we know that these temperature differences can cause problems for our plants, both good and there might be some good issues. Cooling, the wind can cool things, but cooling winds also cause more transpiration because winds blowing across leaves dries things out. Right? We can cause mechanical issues. So if you look at these trees in this image, you can see the direction of the wind that's been blowing on them on a regular basis. So that can cause structural problems for our trees. So that can cause problems for plants in the ground for a long period of time. We can modify the wind a little bit. We can build walls. Our houses obviously modify the wind. We can have berms. We can plant trees. We see this along freeways, not only for sound reduction, but for wind reduction as well for the houses just on the other side of the freeways. We plant hedges and trees and screens and windbreaks all along our properties. That's real easy to do on a small scale homeowner perspective. For you large scale growers, what you're looking at is leaving sections of woods between fields perhaps, and maybe you're doing that because the ground isn't necessarily conducive to plowing, it's down a ditch or something like that, but that has also the added benefit of serving as a windbreak. It doesn't work for a very long period of time. So what we're looking at here is the distance downstream or downwind of the break, and notice the reduction in wind, but as you get further and further away from that windscreen, then you don't see that reduction as much. Not many people are going to build a structure to protect a farm field. Not many people are going to build a structure to protect a large greenhouse or nursery facility, but you might leave trees up. You might build structures on a small scale. All of our homeowners obviously have a structure called the house. They might have a garage. They might have a shed. Those are things that are going to change this. Leaving those windbreaks, leaving those natural windbreaks are places for wildlife as well. And we can conserve water loss, and we can slow the wind down. And anytime we can slow the wind down, that's a good thing, because then it also means we have less soil loss and soil runoff from wind erosion. So there are both pros and cons. You're probably not going to be building any man-made structures as a windbreak on large scales, but you might for small scale. Okay, as always, if you have any questions, do not hesitate to get in touch.